Bismillahirrahmanirrahim. We are going to start the remaining part of our circuit theory, and here we are going to start from the next chapter, and the name of this chapter is network theorems. The first theorem which we are going to study is superposition theorem. Before starting this theorem, let me to introduce why we use this theorem. Before these theorems, you studied the mesh analysis and nodal analysis. There you seen that in a network, if we have more than one sources, then we need to use such type of analysis like the nodal analysis and the mesh analysis, and different methods are there to solve them. Now the superposition theorem is also used for the same type of networks, but it gives us an easy way to solve such circuits. Basically, the superposition theorem tells us that if you have a circuit in which there are more than one sources, like this circuit there are two sources, then what you do, you take the effect of one source at a time and neglect the second source. Like for example, here is current source, you take the effect of the voltage source and solve the circuit. Then for the next time, you neglect the first source, which is voltage source over here, and take the effect of the current source and then solve the circuit. And in the third step, or whatever sources are there in the last step, what you do, you take the algebraic sum of the effect of each source which you taken. Then that algebraic sum would be equal to the effective value of current or voltage produced in that circuit. For example, in this circuit, we need to find out current over here. So what we do, first we select voltage over here and neglect the current source. I will tell how to replace the current source or neglect the current source. We solve the circuit and we get the current over here. We name that current as I1 or I dash. The next time we neglect this voltage source and select the current source, and again we calculate the current over here, that would be I double dash. And in the last step, what we do, we take the algebraic sum of the both currents, that is I dash and I double dash, and that would be equal to the exact value of current which is flowing over here. Now come to the definition of the theorem. The theorem is defined as the current through or voltage across any element of network is equal to the algebraic sum of currents or voltages produced independently by each source. So the same explanation as I gave. Here two words might confuse you, that the one word is the algebraic sum. Algebraic sum means such type of a sum in which you consider both the negative values and the positive values. And here the independently means that you take once, when you take one source, then other source will not affect the value of current of flowing in the circuit. So independently you consider one source at a time. So according to this definition, we do the same work as I explained. Now let us come for the first example as given in this circuit. So you already know that how we are going to solve it. Let us solve. So according to my explanation, what we will do, we will take one source at a time. So the rule given for this is that if there is any current source and you want to replace it, then you can replace the current source by, like this is a current source, you can replace it by what? By open circuit, just like this. And if there is any voltage source, then you can convert it into short circuit. Like if the voltage source is between these 2 points and we want to replace it, we can replace it by a short circuit to check the effect of other. Now here in this circuit, now if we take the voltage source, we will replace the current source by what? By open circuit. And next step, when we take the current source, then we will replace the voltage source by what? By short circuit. Yes. So now let us come for the equivalent circuit according to this rule. So first we take the voltage source. I am taking the voltage source and going to solve this circuit. I am taking the voltage source, and here the current source was over there, which I left open. That is, I replaced according to this rule. Replace the current source by open circuit. Yes. Now this circuit is very simple. 30 volt is over here, and what our target is? Our target is to find current over here. So the target would be given to you, whatever the voltage or current you need to find out. So for this time, the current which we are going to find over here, we name this current as I dash, and we are going to find out I dash. Next time we will take I double dash. So now the 6 ohm resistor is over there. You know how to solve it. So there is simply a series network, and for series circuit what we use, we simply use the Ohm's law to find out current. As you know, V is equal to IR and I is equal to, according to Ohm's law, V is equal to IR and I is equal to V divided by R. And in this circuit, the V is, and this current this time is I dash, so I dash is equal to, I is equal to V divided by R. And what is the voltage value? That is 30 volt. So 30 divided by, and the resistance value is 6 ohm. 6 5s are 30. So we get what? We get 5 ampere of current. We also need to mention the direction of the current. According to this, the current is going downward. According to conventional current direction, current is going like this. So now this step is clear to you people, that if we solve the circuit for the first step, for the first source, the value of current would be I dash, and I dash would be 5 ampere over here. Because we neglected the current source, we replaced it by open circuit. So for the next time, what we will do, think about, yes, we are going to apply this formula. We will replace the voltage source by short circuit, and we will keep the current source by its place. So let us come for the next step. This is our circuit. So this time what we will do, we will replace the circuit by what? We are going to take the current source. So what we need to do, we need to convert the voltage source into short circuit. Instead of open circuit, this time we are going to replace it by short circuit, and the current source would be at its original place. Now we need to find out current over here. That is our target, and this is our target, and this current we will name the I double dash this time. Why? Because last time we named it as I dash, this time it would be I double dash. Now the answer is very simple. I will provide you proof, but without any proof you can directly see that the current, for the current there are two ways. One way is going towards the resistor and the other way is going towards the short circuit. So which way the current will flow, or which way the maximum current will flow? Definitely all the current will flow towards the short circuit and no current will flow toward the resistor. But why it will happen? Let us use the current divider rule, as I explained before the midterm examination. So I will prove this point according to current divider rule. What the current divider rule says? Current divider rule says that if you find out current value in such path where two paths are in parallel to each other, this is short circuit and this is a resistor. You know that the resistance of the short circuit is equal to 0. So the current divider rule says that R opposite divided by R1 plus R2. This is our R1, this is R2, which is short circuit, and we are going to find out current. So here we will take what? The short circuit resistance. So the opposite resistance is what? RSC, that is short circuit resistance, divided by R1 and R2. So it means that the short circuit plus the R value, that this is the R value which is over here, which is the 6 ohm, and multiply by what? This is our I double dash, multiply by total current flowing over there. Total current is the source current which is coming. So if we solve it, it would be the short circuit. You know that the RSC is equal to 0 ohm because it is short circuit, there is no resistance. So it means that 0 divided by 0 plus whatever the resistance value is. Here the resistance value is 6 ohm. So 6 ohm, and multiply by the current value is, what is the current value? The current value is, yes, yeah, 3 ampere. So 0 divided by anything is equal to 0. 0 multiplied by anything is equal to 0. So the answer is what? The answer is 0. So 0 ampere is current is flowing, whatever their direction is, it is 0 ampere. Now in the last step, as the theorem says, that take the algebraic sum of each current and voltage produced by each source independently. Now we will take the algebraic sum. So how we will take the algebraic sum? We needed to find out current over here, so that current we named is I. So I would be equal to I dash plus I double dash. 0 ampere don't have any direction, so we do not need to mention any direction. So that's why I do not consider any negative value over here. We will just add them. 0 add into anything will remain that thing. So here our, see, in first step we calculated the value of current, that was 5 ampere. I dash value is 5 ampere. So I dash is 5 plus I double dash is 0. So that is equal to 5 ampere. So if you want to solve this circuit by nodal analysis or by mesh analysis, the answer will remain same, and the direction of current is this. Thank you very much.